हेलो स्टूडेंट्स, वेलकम बैक। आज है 3.5 ड्रिफ्ट ऑफ electrons and the origin of resistivity. As remarked before, an electron will suffer collisions with the heavy fixed ions, but after collision it will emerge with the same speed but in random directions. If we consider all the electrons, the average velocity will be 0 since their directions are random. Thus, if there are n electrons and the velocity of the ith electron I is equals to 1, 2, 3 up to n at a given time is Vi, then 1 by n xylem naught Vi is equals to 0. Summation. It is summation. I hope you know this. Consider now the situation when an electric field is present. Electrons will be accelerated due to this field by A is equals to minus capital E by M. Here I am not giving you the intro of the symbols because it is always given below it. So don't think, okay, that I am not giving you the full forms, what there is meaning to them. Let's go. Where minus E, this one E, is the charge and M is the mass of an electron. Consider again the ith electron at a given time t. This electron would have had its last collision sometime before t, and let Ti, that is T initial, be the time elapsed after its last collision. If V initial was its velocity immediately after the last collision, then its velocity V initial at time t is V initial is equals to V initial, I think here is mistaken, plus minus E capital E by M Ti, that is initial timing. Since starting with its last collision, it was accelerated with an acceleration given by equation 3.15, that means this equation. For a time interval Ti, the average velocity of the electrons at time t is the average of all the Vi's. The average of Vi's is 0. Since immediately after any collision, the direction of the velocity of an electron is completely random, the collisions of the electrons do not occur at regular intervals but at random times. Let us denote by torque the average time between successive collisions done at a given time. Some of the electrons would have spent time more than torque and some tau and some less than tau. In other words, the time Ti in equation for the before one equation will be less than tau for some and more than tau for others as we go through the values I, that are 1, 2 up to n. The average value of Ti then is tau, known as relaxation time. Thus, averaging over the n electrons at any given time t gives us for the average velocity Vd. Vd gives Vi average, this is capital Vi, this is small vi. Take a note, even back it was capital Vi and small vi. Minus E, this is charge, capital E by M mass. Ti average gives 0 minus charge E by M tau minus charge E by M tau. This last result is surprising. It tells us that the electrons move with an average velocity which is independent of time, although electrons are accelerated. This is the phenomena of drift and the velocity Vd in equation 3.17. This one is called a drift velocity. Because of the drift, there will be net transport of charges across any area perpendicular to E. Consider a planar area A located inside the conductor such that the normal of the area is parallel to E. Then, because of the drift in an infinitesimal amount of time delta t, all electrons to the left of the area at a distance up to mod Vd mod delta t would have crossed the area. If n is the number of free electrons per unit volume in the metal, then there are n delta t mod Vd, that is drift velocity mod A, such electrons. Since each electron carries a charge minus E, the total charge transported across this area A to the right in time delta t is minus NEA mod Vd mod delta t dot, actually full stop, sorry. E is directed towards the left, and hence the total charge transported along E across the area is negative of this. The amount of charge crossing the area A in time delta t is by definition I delta t, where I is the magnitude of the current. Hence I delta t gives plus NEA mod Vd delta t. Substituting the value of mod Vd from equation 3.17, the upper one equation, this one. I delta t equals to E square A by M tau n delta t mod E. By definition, I is related to the magnitude of mod J of the current density by I is equals to Ja. Hence, from equations, J is equals to N E square by M tau E. The vector J is parallel to E, and hence we can write in the vector form J is equals to N E square by M tau E. Comparison with equation before, equation 3.13. Let me show you equation 3.13. This is equation 3.13. Please take a note. J gives sigma E. 3.13 shows that equation 3.22, this one, is exactly the Ohm's law if we identify the conductivity rho as rho is equals to Ne square tau by M. We thus see that a very simple picture of electrical conduction reproduces Ohm's law. We have of course made assumptions that tau and N are constants independent of E. We shall in the next section discuss the limitation of Ohm's law. This is an example. Let's go through them. Estimate the average drift speed of conduction electrons in a copper wire of cross-sectional area 1.0 into 10 to the power minus 7 meters square, carrying a current of 1.5 Armstrong. Assume that each copper atom contributes roughly an conduction electron. The density of copper is 9.0 into 10 to the power 3 kg per meter cube, and its atomic mass is 63.5 nu. Compare the drift speed obtained above with thermal needs of copper atoms at ordinary temperatures, speed of propagation of electric field along the conductor which cause the drift motion. First question A. Let's go. This one is the question. The direction of drift velocity of conduction electrons is opposite to the electric field direction, that is, electrons drift in the direction of increasing potential. The drift speed Vd is given by equation 3.18. Vd is equals to I by NEA. I will solve it here for you. Vd is equals to I by NEA. The same thing I will write, but in the different way, in a different form. E is equals to 1.6 into 10 to the power minus 19. This is charge. A 1.0 into 10 to the power minus 7 meters square. A is area. I 1.5 A. This is current. The density of conducting electrons. N is equal to the number of atoms per cubic meter, assuming one conduction electron per Cu atom. This is copper atom. As is reasonable from its valence electrons count of 1. A cubic meter of copper has a mass of 9.0 into 10 to the power 3 kg. Since 6.0 into 10 to the power 23 copper atoms have a mass of 63.5 gram. N is equals to 6.0 into 10 to the power 23 by 63.5 into 9.0 into 10 to the power 6 gives 8.5 into 10 to the power 28 meter minus cube, which gives drift velocity 1.5 by 1.5 into 10 to the power 28 into 1.6 into 10 to the power minus 19 into 1.0 into 10 to the power minus 7. gives 1.1 into 10 to the power minus 3 meter per second, gives 1.1 mm per second. Next question, B. This one, comparing one. At a temperature T, the thermal speed B first of a copper atom of mass m is obtained from the equations. Go through it. And is thus typically of the order of root kBt by m, where kb is the Boltzmann constant for copper. At 300 K, this is about 2 into 10 to the power 2 meter per second. This figure indicates the random vibrational speeds of copper atoms in a conductor. Note that the drift speed of electrons is much smaller, about 10 to the power minus 5 times the typical thermal speed at ordinary temperatures. At an electric second question solution. An electric field traveling along the conductor has a support of an electromagnetic wave, namely equal to 3.0 into 10 to the power 8 meter per second. You will learn about this in chapter 8. The drift speed is in comparison extremely small, smaller by a factor of 10 to the power minus 11. This is a theory based question. Please go through it yourself. And please comment me if you want me to read even these theory based questions, then I will read it for you all. Now let's skip it. I will be waiting for your comments. Next topic, mobility. As we have seen, conductivity arises from mobile charge carries in metals. This mobile charge carries an electrons. In an ionized gas, they are electrons and positive charged ions. In an electrolyte, this can be both positive and negative ions. An important quantity is the mobility mu, defined as the magnitude of the drift velocity per unit electric field. Nu is equals to drift velocity by E. The SI unit of mobility is meter square by Vs. This is velocity and is 10 to the power 4 of the mobility in practical units. Mobility is positive. We have drift velocity E, tau E by m. This is charge. Small e is charge and m is mass. Hence, mu is equals to Vd by E gives E tau by m, where tau is the average collision time for electrons. Here we have completed 3.5. In the next video, you will get the reading of part 3.6. Wait for the video, it will be coming soon. Thank you.